Hey everyone, welcome to this exciting presentation on IoT-based intelligent energy management for EV charging stations, a comprehensive review and analysis. Today I'm going to walk you through a super cool system that's reshaping how we manage energy for electric vehicles. But first, I've got to give credit where it's due. This presentation is based on the amazing research done by Swathi, Dasi, Swarupa, Rani, Bondalapati, Mummidi, Subbaraju, Divya, Nimma, Pradeep, Jangir, Vijaya, Kumar, Reddy, and N. Zareena. So let's dive in and see how this system works. Okay, let's kick things off with the basics. This system focuses on two big ideas. First up is smart energy management. What does that mean? Well, it's all about integrating solar panels, battery storage, and even smart glass to make the most of the energy available. Then there's sustainability. The system helps cut down on fossil fuel use by relying more on renewable energy like solar power. Plus, it uses advanced tech to make everything super efficient. Sounds like a win-win, right? Let's see how they made it happen. Now, how did they figure all this out? Here's the process they followed. First, they ran simulations to test the system under different scenarios, like sunny days, cloudy weather, and even the worst case conditions. Next, they moved on to real-world testing to see if it worked as well in action as it did on paper. Finally, they used some cutting-edge tools like solar panels for energy, VRFB batteries for storage, and IoT sensors to manage everything in real-time.so. They didn't just stop at theory, they took it all the way to practical testing. Here's where the magic happens. Check out this diagram. At the top, we've got solar PV panels on the roof collecting sunlight and turning it into energy. That energy is stored in the VRFB batteries, which is super helpful for keeping things running smoothly when the sun isn't shining. Then we've got switchable glazing. Yep, that's smart glass. It can switch between transparent and opaque modes to save on cooling or heating. And don't worry, if the sun isn't doing its job, the system is also connected to the EC grid as a backup. Alright, let's break this down step by step. The solar panels send energy to the batteries or directly to the building glazing load like the smart glass or HVAC system. If the batteries run low, the grid kicks in as a backup. All of this is controlled by an intelligent central controller. Think of it as the brain of the system, making sure everything runs smoothly. Red lines show the power flow, and the blue ones are for communication. This setup keeps the system efficient and reliable, no matter the conditions. Now, here's where IoT Internet of Things really shines. On the left, you've got smart meters keeping track of energy from the building, solar panels, and grid. All this data is sent to a Raspberry Pi processor. Yeah, that little computer is managing everything. It decides where the energy goes, whether it's to the building, the batteries, or somewhere else. And on the right, there's a dashboard where you can monitor it all in real time. Plus, the system uses an MQTT broker for super fast communication. This setup makes sure the system is always working at its best. So how did the system perform? Let's look at the results. Sunny days, no problem. It met all energy needs and even sent extra power back to the grid. Cloudy weather. The batteries stepped in to keep things running smoothly. Prolonged cloudy periods. The grid and batteries worked together to keep the EV chargers going. Worst case scenarios. This showed some areas for improvement, like making the system even more efficient during long stretches of low solar energy. Overall, the system proved it can handle just about anything. Every system has its pros and cons, right? Let's break it down. Strengths: it's super smart. Thanks to the IoT-FB batteries and switchable glass. They tested it thoroughly, both in simulations and in real life. It's designed to optimize both energy use and the infrastructure itself. Weaknesses: there's not much long-term real-world data yet, so we don't know how it performs over years. And they haven't really crunched the numbers on cost effectiveness, which is a big deal for scaling UP. Fixing these would take this system to the next level. Here's what's next for this system: scalability. They need to scale it up to handle bigger EV networks and higher energy demands. In extreme weather, the system needs better algorithms to deal with things like storms or long periods without sun. Let's see cost effectiveness. A deep dive into the economics will help make this system more attractive for large-scale adoption. Tackling these challenges will make this technology even more powerful and practical. Alright, let's wrap it up. First, this system is all about sustainability, offering a green and efficient solution for EV charging. Second, it lays the groundwork for future smart grid innovations. And finally, by combining IoT-FB batteries and switchable glazing. And it's creating a seamless and intelligent energy management process. This system shows us how technology can meet the energy challenges of today and tomorrow. That's it for today. Thanks so much for watching and learning about this awesome IoT-based energy management system. I'm open to any discussions, so drop them in the comments or let me know what you think. Thanks again, and I'll see you next time.